Okay, so we were doing May-June 2023 paper 2-1 and we have done till here. And now we have to start with question 3D part 2. One of the product of the reaction is CH2Cl2, which is also called dichloromethane, which reacts further to produce trichloromethane, CHCl3. Its another name is chloroform. Complete table 3.12 to show details of the mechanism that forms CHCl3 from CH2Cl2. Okay, if they have asked you the initiation step, so if you guys recall, in initiation step, there is always a chlorine molecule or a halogen molecule broken down into radicals. So you have to do this. Is this understandable? Okay. Now, if you recall this step, the propagation one, in this propagation, they have given you the organic compound with a chlorine radical. So what happens that the organic compound broken down, a bond is broken down homolytically, and as a result, it will turn into CHCl2, and that forms a radical, right? And the hydrogen that is removed from here bonds with the chlorine radical to form HCl. And then in the termination, as they have formed CHCl3, so what we are going to do, it means that in termination, two radicals joins to form a molecule. So one radical would be a chlorine, and the other radical would be the one which is formed in the propagation, which is CHCl2. So when CHCl2 radical and a chlorine radical bonds, we will get CHCl3. Is this understandable to all of you? Yes, if anyone of you has any query, any question, please ask. Okay. Now we have a E part. Am I audible to all of you properly? In part E, my screen is stuck. Let me share it again. Yes. Okay. In E part, if you see it, trichloromethane, chloroform, and fluoride are used to form CHClF2 in a substitution reaction. Construct an equation for this reaction. So if you see, it is very understandable that there are three chlorines, and out of these three chlorines, we are left with the one chlorine. So see, as they have mentioned, that CHCl3 is reacting with hydrogen fluoride to form CHClF2, right? So see how many fluorines are substituted to. So we are going to put a 2 over, and two chlorines gets removed from here. So there are two hydrogens, that two chlorines bonds with two hydrogens to form HCl. Is this 2 moles of HCl? Is understandable to all of you? Okay, just give me a minute, please. Now, part F. X is a product of the substitution reaction that occurs when CHClF2 reacts with Br2. Okay. There is only one naturally occurring isotope of fluorine. Okay, that is F19. The mass spectrum of X shows molecular ion peak at Me 164. So it means that is M plus peak. One C, it has a 2 units greater than 164. So further, if it's a M plus peak, as they have mentioned that it's a molecular ion peak, so the MR of the compound would be this. At 167, we get the M plus 2 peak, and at 168, we are getting M plus 4 peak. The table 3.3 show all the molecular ions responsible for each peak. Okay. Now, we have to complete this table. Now, if you see over here, as they have mentioned that the chlorine has a, you know, uh, isotope that is chlorine 15. But if we chlorine 19, if we talk about a bromine, bromine has a two isotopes. One is bromine 79 and one is bromine 81. So the first molecule, okay. So the first thing we have to understand is that which atom is substituted by bromine. So there is still one hydrogen in this molecule, right? So the probable chance is that when CHClF2 reacts with the bromine, we got hydrogen substituted. And when the hydrogen is substituted, we get CBr, ClF2, and HBr. So now try to calculate its molecular mass, MR, for example, when we have carbon 12, bromine 79, chlorine 35, and fluorine 19 times 2. Can anyone add them and tell me the answer, please? Okay, my screen is again stuck. Walaikum Assalam, Hassan. So, a little two parts, Umar. Yeah, can anyone add them and tell me the answer, please? I think 12 plus 79 is 91. 91. 130, 126. 126 and 8 is 134 and 30. Is it 164? Yeah. So it's 164. So it means over here at 164, the compound the uh, species or the molecular ion would be C with the bromine 79, chlorine 35, and F2. Because fluorine has a only one isotope, so there is no need to write the uh, nucleon number or the mass number of the isotope. Is this clear? Okay. Then they have asked you, if you see at 166 and 168 and 168, what they did, that they increase bromine with the 2 and they increase chlorine with the 2, right? So if we just keep the chlorine same and just increase the mass of a bromine with the 2 unit, all the molecular ions. So see, so there are two possibilities for 166. One is C with the 79 Br and chlorine 37 F2, and the second would be C carbon with the bromine 81, chlorine 35, and F2. In both the cases, if you calculate the MR, you will get 166. I did. In this case, when I compare these two, I just increase its mass by 2. So obviously it is going to be 166. keep all the masses same. And when we did these, I kept this one same and I increased the mass of bromine with the 2 unit. You have to remember that what we have studied in mass spectroscopy, that bromine has a two isotopes, Umar. One is bromine 79 and one is bromine 81. Is this clear to all of you? Okay. Now, question number 4. V is a colorless liquid. Okay, if you see V, in V there are two functional groups. One is alkene and the other one is carboxylic acid. V reacts with an excess of lithium hydroxide to form W. Draw the structure of W. So if you recall, it's a reducing agent, right? And it reduces, if you recall, it reduces carboxylic acid, it reduces carbonyl, which means aldehyde and ketone, it reduces nitrile. And here we have a carboxylic acid. So in W, carboxylic acid got reduced, and whenever carboxylic acid get reduced, it always primary alcohol. So I'll make it, I keep the double bond same. See, there are one, two, three, four carbons. And the first carbon, which has a carboxylic acid, I'm going to put a OH over there only because now it's reduced to primary alcohol. Yes, very good, Banin, very good, Umar. So that will be the product of W. Now, what they are asking, identify the role of lithium aluminum hydride in the reaction with V. So we have just already discussed that it's a reducing agent. So I'm going to state or write over here that it's a reducing agent. Is this clear to all of you? Now, part B, V. Okay, here the structure is of V. Reacts to form in a single reaction as shown in figure 4.2. Okay. Suggest the conditions needed to form Z from V. So if you see, there is a carbon-carbon double bond, and instead of that carbon-carbon double bond, we got a diol on those two carbon. So what are the reagent and condition? Can anyone recall? Yes, it's cold, dilute, acidified KMnO4. If you just write cold, you will not get the mark. If you just write dilute, acidified, you will not get the mark. You have to mention both cold and dilute. Okay. So cold, dilute. Only Fatma got the correct answer. Banin and Hassan gave me incomplete answers. Cold, dilute, acidified, KMnO4. Okay. Now, reduce the empirical formula of Z. So if you look at Z, 1, 2, 3, 4, there are 4 carbon atoms. Now count hydrogen. After carbons, there are 2 hydrogen over here, 1 hydrogen over here, 2 hydrogen over here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. Now, if we count the oxygen, 1, 2, 3, 4. So 4 oxygens, right? So if I simplify it, on simplification, I will get CH2O. Yes, very good, Hassan. CH2O is empirical formula. Okay. Now, next part. Complete table 4.1 show the number of sp2 and sp3 hybridized carbon atoms that are present in a molecule of V. Okay, if you look at the molecule of V, it's this. Okay, here we go. Let me draw it over here. So Here we got a V. What fizza? Okay. Now, if you see, there are two carbons with a double bond, and the double bonded carbon are called sp2 hybridized, right? Are sp2. And if you see, there are three carbons which are sp3 hybridized. This one, and this one. These three are sp3 hybridized, and this one is sp hybridized, right? So this one is sp. This is, oh, sorry, this one is sp3 because all single bonds, and these has a pi bond, these three. So these three are sp2 hybridized. So over here, I'm going to write 3, and over here, I'm going to write 1. Yes, Fiza, what part A part 1, what you were asking? Yes, we are reacting with the LiAlH4 to a W, and LiAlH4 lithium aluminum hydride is a reducing agent, and it reduces these functional groups: aldehyde ketones, carboxylic acid ketones, and nitriles. So when carboxylic acid undergo reduction, it will turn into a primary alcohol, right? And that's why this carbon is a carboxylic acid, the carbon number 1. So carbon, a carboxylic acid, and alcohol. Is it clear now? Okay. Now C part. Q contains the elements carbon, hydrogen, and oxygen only. It is saturated molecule. It means the bonds between carbon are single covalent bonds with no branching in its carbon backbone. So it means it's a straight chain structure, right? Okay. Q contains only one functional group. The relative molecular mass of Q is 88. Okay. No effervescence is seen with when sodium carbonate is added to Q. So it means, okay, not carboxylic acid. Which part? Yes, Fatma. If you look at this structure, if you see it's a V, here we got a carbon here, here, and here. There are 4 carbons, and out of uh yeah, if you see 1, 2, 3, 4, there are 4 carbons, right? And out of these 4, see, these 3 carbons have a double bond. So the carbons which have a double bond are sp2 hybridized. So there are 3 carbons which are sp2 hybridized. And this carbon has a 2 single bonds, so it means that it has a 2 more single bonds with the hydrogen atoms. So there is a 1 carbon which is sp3 hybridized. Is this clear? Pisa, I hope you understand part A1 LiAlH for reducing agent 1. Okay. Now, so it's a saturated molecule Q. It contains carbon, hydrogen, and oxygen only. Okay. It is a saturated molecule, which means no double bond. One functional group only. Mr is 88. It does not react with sodium carbonate, which means not carboxylic acid. Effervescence is seen when sodium is added to Q. So that is the important thing. On adding sodium, we are getting the effervescence, but with sodium carbonate, we are not getting effervescence. So it means it contains an alcohol. No, Umar, xp2 is the one which forms a pi bond. If an atom is forming a 1 pi bond, if a carbon, oxygen, and nitrogen is forming a 1 pi bond, then it is sp2 hybridized. And if it is forming all single bonds or all sigma bonds, then it is sp3 hybridized. Okay, so the Q contains OH functional group. Q reacts with alkaline iodine to form yellow precipitate. So see, if it's an alcohol and showing yellow precipitate, so it means it contains this structure for sure. And here we have other thing. Is this clear to all of you? Yes. Okay, now think. Now we don't know the whole molecular formula, but we know that it is an alcohol. So it for sure it's an alcohol. So it follows this general formula CnH2n plus 2O. Right? If it contains CnH2n plus 2O and its MR is 88. So let's put the values. Yes, for carbon, nitrogen, and oxygen, that is correct what you said, Umar. Okay, now, so there are 12N because the AR of carbon is 12, and then plus hydrogen is 1 times 2N plus 2, and for oxygen it's 16 is equals to 88. So it becomes 12N plus 2N plus 2 plus 16 is equals to 88. So if I add them, I'll get 14N plus 18 is equals to 88. So N is going to be equals to 88 minus 18 over 14. So can anyone solve it and tell me what is the value of N we are getting? 88 minus 18 would be 70, and 70 divided by 14 is 5. So see, we got the value of N. It means there are 5 carbon atoms. So how many carbon atoms I have made? So it means there are 3 more carbon atoms. And this carbon atom is going to have a 2 hydrogen. This carbon atom is going to have a 2 hydrogen. And this carbon atom has going to has a 3 hydrogen. So if you look at the molecular formula, it is going to be C5H12O. Now can you calculate its MR? You are going to get 88. So the MR would be justified. 12 times 5 plus 12 plus 16. So 12 times 5 would be 60. 60 plus 12 plus 16. 12 and 16 are 18. Oh, sorry, 28. So it is going to be 88. It is due to this thing, see, as I have told you earlier, that if first we got to know that it's an alcohol because it is reacting with sodium and not reacting with sodium carbonate. So it's not carboxylic acid, but alcohol. But then it is reacting with an alkaline iodine. So it means this indicates me that this alcohol has this group. Then further, we work to find the number of carbon atoms, and it shows that it's a straight chain, right? So the structure would be CH3, C having a OH, H, and then CH2, CH2, CH3. Is this clear to all of you? Okay. Now, question number 5A. Molecule M is present in petrol, a fuel used in cars. M is a saturated, means all single bonds around carbon atoms. Non-cyclic hydrocarbon. M contains 8 carbon atoms. So it's a saturated and non-cyclic hydrocarbon. So it means it is going to be an alkane, and the general formula of alkane is CnH2n plus 2. So the molecular formula of this, as it has a 8 carbon atoms, so the value of N is going to be 8. So it is going to be HC8H18. So write an equation, construct an equation for the complete combustion of M. So as it's C8H18 plus oxygen, and it's a complete combustion, so it means we are getting carbon dioxide and water, right? So there are 8 carbon atoms, so I'm going to put over here 8, and there are 18 hydrogen, so I'm going to put over here 9. 9 times 2 makes it 18. So if you see, there are 16 oxygens and there are 9 oxygens. So 16 plus 9 gives you 25. And here there are 2. So I'm going to put 25 over 2. So which becomes equals to 25. Is this clear to all of you? Okay. Now, 5A part 2. Describe how the composition of products differ when incomplete combustion of M occurs. So it's for 2 marks. And we know when there is an incomplete combustion, we got carbon monoxide. But see, you are not going to just write carbon monoxide. We get unburnt hydrocarbons as well. And as black suits are can be seen, so and carbon only as well. Is this clear? So these are the products, and further you can also write that there would be a less amount of carbon dioxide. Okay. Now B part. When petrol is burned in an internal combustion engine, oxides of nitrogen are released into the atmosphere. Oxides of nitrogen are responsible for the formation of acid rain. Okay, so that is from nitrogen and sulfur chapter. Suggest the conditions required for the production of the oxides of nitrogen during the combustion of M in an internal combustion engine. Use an appropriate equation to show your answer. Okay, so if you recall, there are two things which leads to the formation of oxide as nitrogen and oxygen reacts with each other, and these are inside a car engine or inside an internal combustion engine, there is a high temperature. Yes, very good, Hassan. And high pressure. So both of these conditions leads to the reaction. Okay. Now, nitrogen and oxygen reacts to form nitrogen monoxide. That's what produced in car engine. So to balance the equation, I need to put a 2 over here. Is this clear? Okay. Now, what they are asking in the part 2, describe how acetylene is formed in the atmosphere in the presence of oxides of nitrogen and SO2. Identify the roles of oxides of nitrogen in this process. Include all relevant equations. So if you recall, the oxide of nitrogen that is present in the atmosphere is NO2, because as soon as the nitrogen monoxide NO, very good Bunny, dissolve escapes into the atmosphere, it reacts readily with oxygen to form nitrogen dioxide. So nitrogen dioxide, its role we have to mention it. So it act as a catalyst. And now we have to write the equations. So the first equation would be and it it act as a catalyst. If you will write the complete thing, that to convert SO2 to SO3. So in the first equation, nitrogen dioxide reacts with sulfur dioxide and it loses its one oxygen to sulfur dioxide. As a result, sulfur dioxide forms sulfur trioxide. And nitrogen monoxide is formed. Okay. Then nitrogen monoxide, as it's formed, it reacts readily with the oxygen to form nitrogen dioxide back. So see, that is how it shows that it's a catalyst. And what happens to the sulfur trioxide? Sulfur trioxide reacts with the rain or dissolves in rain to form acid rain, with rain to form sulfuric acid, and that sulfuric acid causes acid rain. So for this, the equation would be sulfur trioxide In a ring, there is a water. It dissolves in water to form H2SO4. Now, state one, other type of air pollution that is caused by the production of oxides of nitrogen in an internal. So yes, what is the other type of pollution? Who can recall? Yes, very good, Hassan. Very good, Alize. It's a photo smoke, and which is caused by the formation of PAN, which, right? So till here, is this clear to all of you? Okay. Now, 5 part C. Biodiesel T is a fuel made from vegetable oil R. Figure 5.1 shows the production of T from R in a two-step process. Okay. So if you guys look over here, isn't it this thing is this part of the molecule? And we are getting hydrogen over here. So it means that over here, hydrolysis occur, and basically acidic hydrolysis occur. That's why carboxylic acid is formed. So this and this bond is broken, and the OH from the water got bonded with these carbons to form this. So the J would be H2CO. That C is bonded to a CH, and that CH is bonded to CH2. And we got a O over here. And on that O, the H from the water gets bonded to form the another hydrolysis product. Is this understandable? So if you see this whole thing gets over here. Okay. Now, if you see this L in a step 2 reacts with the G to form this. If you see that what change we are observing over here, that this H is displaced by this CH3. And if you see here, it's an ester. So it clearly helps me to identify that G is CH3OH, because as OH from here and H from here is released, and this O got bonded over there with the carbon, and as a result, we got this. Is this understandable? Okay. Now, what they are saying in step 1, part 1, all the 3 ester groups in R react, suggest a suitable reagent and conditions for step 1. So for this kind of a reaction, we can write any acid. Yeah, it's a acidic hydrolysis. Yes, Umar, very good. So the condition would be heating, and we use a dilute nitric acid, dilute hydrochloric acid, dilute sulfuric acid. Okay. So dilute sulfuric acid and heat. Draw the structure of the formula of J in box figure 5.1. So we already did it. Name the type of reaction that occur in step 2. So yes, an ester is formed. Which type of reaction is it? Yes, very good, Bunny. It's a condensation reaction. Name the organic compound G used in step 2. So we have already identified that G is CH3OH. So the name would be methanol because it has a one carbon and an alcohol. So it is methanol. It's a primary alcohol. It has a one carbon only. And okay, J is called triol. See, there are three OH groups in it. So it is called triol. Okay, now, yes, is this clear to you, Umar? L is called decanoic acid. Use systematic nomenclature to deduce the name of T. Okay, so see, they have given you the hint over here. Whenever the carboxylic acid, when the ester forms, the carboxylic acid part turns into alkanoate. So it's a decanoic acid. So it means that the last part of the ester would be decanoate. And alcohol has a one carbon. It's a methanol. So the alcohol parts then name become alkyl. So the systematic name of the ester would be methyl decanoate. Yes, very good, Bunny. Is this clear to all of you? Okay, so here we are ended with the May June 2023. Okay, now tell me, do we start the February 24 in the next class or October November 23? I'm thinking that first we do February March 2024 and then we will start for November 2023. Part 4. Fatma, you are asking about this part? Yes, Fatma. Okay, so see over here, we have just figured out that see there is a H, this H is substituted by CH3 and it's an ester, right? And this compound is reacting with the G. So G must be a one carbon containing alcohol, methanol, because we got only one carbon over here. Is this understandable now? Okay, so tomorrow I think we have a class at 5 p.m. PST and we are going starting the new paper, inshallah. Okay, so see you everyone in the next class. Take care. Allah Hafiz.